Hello, this is group 4, and now we're gonna present you the statistic tutorial question. And here is our group member information and the corresponding question.
Hello everyone, I'm Li Xinke from Group D. Let's look at question 4.2. This is a question about proportional sampling distribution. When mu and sigma are unknown and n is greater than 30, it conforms to the central limit theorem. Therefore, from the question, mu is 0.3. According to the variance formula, the following formula can be obtained. The proportion of students majoring in statistics conforms to the normal distribution. At this time, mu is 0.3 and sigma is 0.0021. When x is greater than 0.24, the following formula can be obtained. And when x is less than 0.28, the following formula can be obtained. In the end, 24% to 28% of students have a probability of 0.2349 to major in statistics. Thank you, and let me pass the time to the next team member.
Hello, this is Fengxi Si, and now let me present you the answer of question 4.3. Now first, let us go through the question. A mask selling company wanted to estimate a population made of monthly sale for their 250 salespeople, and 40 salespeople were randomly selected. Their main monthly sale was 10,000, with a population standard deviation of $1,000. So now we should construct a 95% confidence interval for the population mean. Okay, so the first step we have to write down x with normal distribution with the mean of 10,000 and the variance of 1,000 square. Because n is equal to 40 and is bigger than 30, so we should use CLT to estimate the normal distribution of sample. And the mean of sample is equal to the mean of population, which is 10,000. And the variance should be 1,000 square divide 40 by the formula of and the variance of this equals to variance of population divide the sample size. We can know that the alpha is equal to 1 minus 95%. Half of alpha would be 0.025, and its z would be this one. And according to the z distribution form, we can find that it is equal to 1.96. And now we can calculate the confidence interval. Upper limit is calculated by this formula. And for the lower limit should be calculated by this formula. So now we can put our number in it. And by the calculator, we can know the answer is, and then we can calculate the lower limit by putting the number. It is equal to 9690.098. And this is the final answer. Thank you for your listening.
And now we'll move on to question 4.4. To investigate the daily expenditure of the university students in Hong Kong, a sample of 64 students were interviewed and resulted in a sample mean of $252.45 per day, and a sample standard deviation is $74.5. Develop a 95% confidence interval estimate of the population mean amount spent per day for an university student. It's assumed that the population distribution is normal. And the solution is, from the question, we need to calculate the estimate of the population mean amount spent per day for a university student. For 95% confidence interval, alpha is equal to 0.05 and z is equal to 1.96. Also, mean is equal to $252.45, standard deviation is equal to $74.5, and the sample number n is equal to 64. By the formula, a 95% confidence interval estimate of the population mean amount spent per day for a university student is equal to $252.45 plus minus 1.96 times 74.5 over square root of 64. And the answer is $252.45 plus minus 18.2525. Therefore, the estimate of the population mean amount spent per day for a university student is $234.1975 and $270.7025.
From this question, we can know that there are 100 customers and 80 of them paid by consumption voucher. So the sample proportion is 0.8. From the standard normal distribution table, we can know that the z-value of 95% confidence interval is 1.96. After the above calculation, we can know that the interval is between 0.7216 and 0.8784.
From the question, we can know that we need to calculate the minimum sample size n for 95% confidence interval. Alpha is equal to 0.05 and z is equal to 1.96. The maximum error estimate is equal to 0.04. Let P bar be the sampling distribution of proportions. Estimate sigma P bar squared is approximately equal to P bar multiply 1 minus P bar over n. Through this formula, we can know that n is equal to z multiply P bar multiply 1 minus P bar over e squared. When P bar is equal to 0.5, n can take the maximum value. So n is equal to 600.25. This is approximately equal to 600. So the maximum required sample size is 600.
Hello everyone, I'm Jiang Qianzi. It's my turn to talk about question 4.9. At the beginning, I highlighted several keywords which are essential to help us recognize which equation we need to use, like the first sample, second sample, bachelor's degree, not have a bachelor's degree, 99% confidence interval, normally distribute with equal variance. So let us look at step 1. We assume that x1 is the sample of bachelor's degree, so x2 is the sample of not have a bachelor's degree. For bachelor's degree, the number is 16, which is less than 30. For non-bachelor degree, the number is 12, which is also less than 30. It means that there are small sample sizes. So we should use the equation in step 2. For finding the confidence interval in the difference in population means, the pink part is the sample means, orange part is the rate from t-distribution table for given confidence, and the blue part is the degree of freedom. However, we need to notice that since the population standard deviations are unknown, so we must use t-distribution with v equals n1 plus n2 minus 2. So the sample standard deviation is the purple part. For step 3, we can get x1 sample means by the sum of each sample in step 1 divided by the number of sample 1. We can get answer 525. So the standard deviation of sample 1 is the square root of the equation here. We need to notice that the number should minus 1 since they are sample. So we can also get the answer 59.4205. So use the same equation above, we can get the sample mean and the standard deviation of the sample 2. And so moving on to step 4. The error intel at confidence interval is 99%, is 0.005. So we can get the V is 26. So we can get the answer by checking the t distribution table is 2.779. So we can move to step 5. The standard deviation of the samples are 56.321. So the last step is step 6. Since the variance of two means is the sum of their positive variance, so we can get an answer here. Therefore, the 99% confidence interval is minus 21.52 to 98.02. Thanks for listening. Bye-bye.
Hi everyone, I'm Hu Jiachen, and I'm going to illustrate question 4.10, which related to the confidence interval for proportion difference. Here is the question. First and all, I'm going to state two sentences for this solution. X1 refers to customers who prefer chicken in the West Kowloon. X2 refers to customers who prefer chickens in the East Kowloon. Due to the confidence interval is 95%, we can get A equal to 5%. And here is the equation or formula we will use to solve this problem. According to the A equal to 5%, which is 0.05, we can get A over 2 equal to 0.025. And according to the table of the standardized normal distribution, we can get the Z A over 2 is 1.96. And now, I'm going to calculate some figures. P1 equal to 86 over 193. P2 equal to 13 over 41. And 1 equal to 386. And 2 equal to 492. And we will use these figures into the equation we mentioned before. And we finally got 0.1929 or 0.0641. And finally, we can get the 95% confidence interval is 0.0641 and 0.1929. This is the end of our presentation. Thanks for watching.